Hello everyone, I am Professor Anish Vora and I welcome you all in this video lecture. In this video lecture, we will study about the Boolean equation. We'll simplify Boolean equation, we'll prove Boolean equation, as well as we'll implement the logic circuit for the given Boolean equation. We start with the implementation of logic circuit. So, the instruction given is draw a logic circuit for given Boolean equation, and Boolean equation given, that is y is equal to a plus b bar c. So in the given Boolean equation we can see that we have two terms. First term, that is a single variable, and second term it has two variables b bar c. So we have two terms, and these terms are known as sum of products, SOP. So given Boolean equation is in sum of products. So this is product b bar c, that is a product, and it is a sum. So both the terms b bar c as well as a, both are interconnected with the plus sign, that is OR. So we know that now at the last, when we get the output y, we will have a OR gate, and input of OR gate, one of the input, that is a, and one of the input of the OR gate, that is b bar c. Now to get the b bar c, it is a product, so we will have to use AND gate. One of the input of the AND gate, that is c, and one of the input is b bar. Now to get the b bar, again we will have to use one inverter. So now let us see the circuit. So as I said, we have OR gate, and output of OR gate, that is y is equal to a plus b bar c. Now one of the input of OR gate, that is a directly, and one of the input of the OR gate, that is b bar c. Now we have used AND gate here to get this product b bar c. So input of AND gate, that is one of the input is c and one of the input is b bar. And now to get the b bar, we have used this NOT gate. So b input is given to the NOT gate, it is inverted to get the b bar, and b bar and c as an input given to the AND gate, and at the output of AND gate we are getting b bar dot c, and that we are giving to the OR gate. So given Boolean equation y is equal to a plus b bar c, that is one of the very simplest Boolean equation. We have three inputs, we have three variables, and we have implemented the circuit with the basic logic gates. Now let us see one more Boolean equation and we'll implement the circuit. Given Boolean equation, that is y is equal to abc plus abc whole bar. So again we have two terms, one first term, that is abc a dot b dot c, and second term, that is again a dot b dot c, but it has a whole bar. So complement of abc. Now again the given Boolean equation, that is a sum of product. So we have a sum abc plus abc bar, both are connected with the plus sign, and abc, that is a product, again a dot b dot c bar, that is also product. So this term is known as a sum of product. So when we have a sum of product type of Boolean equation, at the output we always have a OR gate, because we do the addition of all the inputs. So now let us try to implement the circuit. We have ABC bar, whole bar. So ABC, that is a AND gate, and if we invert the output of the AND gate, then we have ABC bar. So instead of using AND gate and NOT gate, we simply use NAND gate. Another term, that is ABC, A dot B dot C. So here we have to use AND gate. We have three inputs, A, B and C. Same inputs we are giving to the AND gate also. Output of AND gate, that is A dot B dot C, and output of NAND gate, that is A dot B dot C bar. Now this both the outputs we are giving to the as an input to the OR gate. So we have one OR gate, we are giving one input A dot B dot C bar and another input, that is A dot B dot C. So both the input we have given and we get the output of the OR gate, that is Y is equal to ABC plus ABC bar. So this way it is very simple to implement any logic circuit for any given Boolean equation. But sometimes we have a Boolean equation which can be simplified, and if it is simplified, then with the less number of gates we are able to implement the logic circuit. Now we have second part. We'll have to prove given Boolean equation. So prove using Boolean algebra. So one equation is given, that is A plus A bar B plus AB bar, and that is equal to A plus B. We have to prove this Boolean equation. It is very simple. So first we start with the left hand side. So left hand side it is given A plus A bar B plus AB bar. This is also one of the form of Boolean equation, and that is known as a sum of product. Now let us rearrange the given Boolean equation. We have written A plus AB bar plus A bar B. So second and third term we have interchanged. A bar B plus AB bar we have just interchanged. Now from the first and second term we are taking A as the common output. So A into bracket 1 plus B bar plus A bar B. Now in case of 1 plus B bar, we know that it is an OR function. If one of the input of OR function is 1, then output will be 1. So it is A 1 A dot 1 plus A bar B, because 1 plus B bar, that is 1. Now it can be written as A plus A bar B, and one of the theorem we have used, that A plus A bar B, that is equal to A plus B, because this theorem we know that A plus A bar B, that is A plus B. So this way we can prove our given Boolean equation. So A plus B, that is right hand side. So left hand side is equal to right hand side. So we can say that we have proved this Boolean equation. Now next part, we are taking just one example of each part. We have implementation of logic circuit, we have proved Boolean equation. Now this is simplification of Boolean equation using Boolean algebra. So we will simplify the given Boolean equation. So one Boolean equation is given, that is A into bracket A bar plus C dot into bracket A bar B plus C. Now this term is known as a product of sum. All the terms, first term, second term and third term, all the three terms are connected with the dot. So it is a product. And into bracket it is OR sign or positive plus sign. So it is known as a product of sum. Now we will have to simplify this Boolean equation. So we write our Boolean equation, that is A bar plus C, A bar B plus C bar. Now we start with the opening of bracket. So this A, we are multiplying with the A bar and multiplying with the C. So this first bracket we are opening. So it comes as A bar plus AC, A bar B plus C bar. Now A dot A bar, we know that it is 0. So 0 plus AC plus A bar B plus C bar, because A dot A bar, that is equal to 0. So again we write as AC plus A bar B plus C bar. Now again we have to open the bracket. So we do the multiplication of AC with A bar B as well as with the C bar. So AC A bar B plus AC C bar. If we rearrange the terms, then we can write as A bar BC and A C C bar. Now again A dot A bar, we know that it is 0. Same way C dot C bar, that is also equal to 0. So we can write as a 0 dot BC plus A dot 0. So if we multiply 0 with any term, so 0 dot BC, again it is 0 plus 0 and output is 0. So if we simplify the given Boolean equation, then we will be getting output as a 0. So this is simplification of given Boolean equation. One more example we take. We do the simplification, but now we use the De Morgan's theorem. So given Boolean equation, that is xy bar plus x bar and whole bar, right? So now what we do is we just simplify, but now we have to use De Morgan's theorem. So solution, we write our given Boolean equation as it is. So xy bar plus x bar and whole bar. So now what we do is the red bar, that is a whole bar, we are not doing anything for the whole bar, but for the xy the bar is given. So if we apply for this xy, bar is given. So if we apply De Morgan's theorem to the first pair, now this first pair is known as a complement of the product. And if we want to change into sum of complements, so what we do is we change our first pair to sum of complements. So instead of xy bar, now we have written as x bar plus y bar. So xy bar is changed to x bar plus y bar. Remaining terms we have written as it is, and whole bar that we have kept as it is. Now if we open the bracket, then we can write as x bar plus y bar plus xy and whole. So we have opened the bracket and we have written the same equation. Now x bar plus x bar, or a plus a, that is equal to a. So we use this x bar plus x bar as a x bar. One of the x bar that is eliminated, plus y bar plus xy and whole bar, because we know that a plus a is equal to a. Same rule we have applied for x bar plus x bar, that is x bar. So now again we have to apply De Morgan's theorem. Here we have x bar plus y bar. So it is a sum of complements. It can be changed into complement of the product. So now let us see what we do is xy bar. So this x bar plus y bar, that is a sum of complements, it is changed to product, complement of the product. So xy bar, so xy bar plus xy, and we have whole bar. xy bar plus xy. So we know that a plus a bar that is equal to 1 and whole bar we have kept as it is. So a plus a bar that is equal to 1. That theorem we have applied for xy plus xy bar. And bar of the 1, complement of the 1 that is equal to 0. So our final answer for simplified, if we simplify the given Boolean equation, then we get the answer 0. But we have used De Morgan's theorem in this simplification. We have studied about the implementation of the logic circuit based on the given Boolean equation. We have proven the given Boolean equation. We have simplified the given Boolean equation. We use different Boolean theorems of Boolean algebra, as well as we have simplified the Boolean equation using De Morgan's theorem. You can do practice on your own. Lot of similar equations are available. You do practice. Thank you for watching my video. Keep watching. Thank you very much.